day, my dear STEM students. Welcome to our session today. In a macro world, gravitational attraction between two objects is strong. For instance, if I drop this eraser to the ground, it falls because of the force of gravity. In contrast, at the subatomic level, the electrostatic attraction between two charges, such as an electron and a proton, is far greater than the gravitational attraction. In this session, you will learn more about this electrostatic force that governs the microworld. In our session today, you will calculate the net electric force on a point charge exerted by a system of point charges. Specifically, you will explain the relationship between electric force and magnitude of the charges, explain the relationship between electric force and distance of separation between charges, and lastly, calculate the net electric force on a point charge due to two or more point charges. In the previous session, you have learned about charges and the methods of charging. Let us recall the key ideas by answering this task. So here is an electroscope. A negatively charged object is placed near an electroscope. What do you think will happen to the leaves of an electroscope? Will they move towards each other or will they move apart? Why do you say so? So you have 2 minutes to write your answers. Were you able to use the concept of the law of charges in answering the question? We need this concept to better understand the lesson in this session. Charges are contained inside an atom. Protons carry the positive charge, while electrons carry the negative charge. When two materials are rubbed together, just like in the examples given in the previous sessions, they become electrically charged. When objects are charged, it has an ability to affect the behavior of objects around it. But how do charged objects interact with each other? Now, I want you to write down your initial ideas on how charged objects interact. Say for instance, we have here the positively charged proton and the negatively charged electron. How does the positively charged proton know the presence of the negatively charged electron? To find out more about electric forces, let's do these activities. Picture analysis number 1, it's about electric force and magnitude of point charges. Study the 3 diagrams shown in the screen. So we have figure 1, figure number 2, and figure number 3. As you analyze the figures, take note the magnitude or size of the point charges and the force. The length of the arrow represents the magnitude of the force. Afterwards, you are going to answer the guide questions. Are you now ready to answer the 3 guide questions? So let's have the guide questions for picture analysis number 1. Number 1, how would you describe the forces acting between point charges? Number 2, if the magnitude of the point charges becomes bigger, what do you think will happen to force between the charges? Number 3, how would you relate electric force and the magnitude of point charges? Okay, now this time, we will proceed to picture analysis number 2. It's about electric force and the distance. So in this task, you will analyze how electric force is affected by the distance. Again, I want you to take note the magnitude of the force represented by the length of the arrow. So after studying the diagram, you will answer again the guide questions. So guide questions for picture analysis number 2. Okay, number 1, what happens to the electric force as the distance of separation between point charges decreases? How about when distance increases? Number 2, how would you relate electric force and the distance of separation between charges? Now, considering the diagrams in picture analysis number 1 and 2, how would you relate electric force to the magnitude of point charges and distance of separation between them? Were you able to answer the guide questions? All of this is described as Coulomb's law. In the next activity, you will find out more about this law. So in activity number 2, the focus is on calculating the electric force. Now I want you to study the table here and find out how I've computed the magnitude of the electric force. Are you now ready to answer the guide questions? So how did you compute the value of the electric force? What equation did you use? In column number 5, notice that the distance between charges is a square. What does it imply about the relationship between electric force and distance between point charges? Now, using the equation that you have derived in question number 1, okay, I want you to solve this problem. In a hydrogen atom, the electron is separated from the proton by average distance of about 5.3 times 10 raised to negative 11 meters. Now calculate the magnitude of the electrostatic force of attraction exerted by the proton on the electron. The charge of the proton is 1.6 times 10 raised to negative 19 coulomb, while the charge of an electron is negative 1.6 times 10 raised to negative 19 coulomb. Now, in part 1, you've calculated the electric force on point charge Q1 due to another point charge Q sub 2. Now, suppose that there is another point charge Q sub 3. What would be the net force on charge 1 due to charge 2 and charge 3? So this would be the focus of our part 2. The force on a point charge due to multiple charges. Now, in dealing with this kind of problem, you are given with this problem-solving tips. Number 1, we have first to find the magnitude and direction of the force exerted by charge 1 by charge 2, ignoring charge number 3. For number 2, we have to determine the force exerted on charge 1 by charge 3, ignoring charge number 2. In number 3, the net force on charge 1 is the vector sum of these forces. Now you are going to apply this problem-solving tips in answering this problem about the 3 charges on a line. So we have 3 point charges lie along the x-axis in the vacuum. Determine the magnitude and direction of the net electrostatic force on charge 1. Okay, so here is a diagram, the diagram of the 3 charges on a line, as well as the free body diagram, or the FBD. Okay, now for our guide question. Now what do you think the force exerted on charge 1 by charge 2 is directed to the left? Number 2, why do you think F1 and 3 is directed to the right? Now using the equation you formulated in activity number 1, compute for the magnitude of F1 and 2. Okay, number 4, what is the magnitude of F1 and 3? And number 5, since F1 and 2 points in the negative x direction and F1 and 3 points in the positive x direction, the net force is the vector sum of F1, 2 and F1 and 3. Now I want you to show your calculation on how to compute for the net force in your notebook. Let's discuss the concept in the activity. Now, charged objects interact or they communicate with each other by means of electric force. Now, electric force or electrostatic force exists between point charges. The force exerted by one point charge to one another acts along the line between charges. So it can be a repulsive or an attracting force. So a repulsive force exists between like charges and an attracting force for unlike charges. So say for instance, if I have a positively charged proton near another positively charged proton, a repulsive force exists between these point charges. So the force is represented by an arrow. Now similarly, if I have a negatively charged object and another negatively charged object, a repulsive force also exists between them. Now if I have a positively charged object brought near a negatively charged object, an attracting force exists between these 2 point charges. But how do we calculate the magnitude of this repulsive force and attractive force? Now to calculate the magnitude of this force, we are going to use the Coulomb's law. It states that electric force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. The law shows that electric force is dependent upon the size of the charges and their distance of separation. So going back to our picture analysis number 1, you've seen that as the size or the magnitude of the charges increases, say for instance, the size or magnitude of charge number 1 and charge number 2, the force between them also increases. If I am going to reduce the magnitude of these charges, the force between them is also decreased. In picture analysis number 2, we are asked, to look at the relationship between force and distance. As you have noticed, as the distance of separation between 2 point charges increases, the electrical force that exists between them decreases. As we decrease the distance of separation between 2 point charges, the electrical force increases. Coulomb's law also follows the inverse square law. So applying the inverse square law in Coulomb's law, you will notice that electrostatic force between 2 point charges varies inversely with the square of the distance of separation between the two charges. That is, the factor by which the electrostatic force is changed is the inverse of the square of the factor by which the separation distance is changed. So if the separation distance is doubled, then the electrostatic force is decreased by a factor of 4. So if we are going to apply that statement in this equation, if I am going to increase the separation distance between 2 point charges, the force will decrease by a factor of 4. Now, if we are going to triple the distance of separation between 2 point charges, by how much factor do you think the force will decrease? Okay, so the force will decrease by a factor of 9. Now, in quantitative form, Coulomb's law is expressed as F is equal to K, Q sub 1, Q sub 2 over R squared, where F is the force on each charge expressed in Newton. Q sub 1 and Q sub 2 are the interacting point charges in coulombs, while R is the distance of separation between point charges in meters, and K is the constant of proportionality, which is equivalent to 9 times 10 raised to 9 Newton that meter squared per coulomb squared. Traditionally, Coulomb's law is written as F is equal to 1 over 4 pi epsilon naught Q sub 1, Q sub 2 over R squared. Now, if we are going to substitute the values of the pi and epsilon naught, which is equivalent to 8.85 times 10 raised to negative 12 coulomb squared per Newton that meter squared, we will come up with a value that's similar to the K, or our constant, which is equivalent to 9 times 10 raised to 9 Newton that meter squared per coulomb squared. Now, this expression of Coulomb's law is helpful for us in our next lesson on Gauss's law. Now, going back to our first problem in our activity, we will use that equation in order to find the magnitude of the electrostatic force of attraction exerted by the proton on the electron. Okay, so in this problem, the given are the charge of the proton, which is 1.6 times 10 raised to negative 19 coulomb, the charge of the electron, which has the same magnitude, but we have a negative sign here, the distance of separation between the 2 point charges, equivalent to 5.3 times 10 raised to negative 11 meters. Then, we are asked to compute for the magnitude of the electrostatic force of attraction. Now, using Coulomb's law, F is equal to K, Q sub 1, Q sub 2 over R squared. We will compute for the magnitude by substituting the given. We have the proportionality constant, the magnitude of the charges, and the distance of separation between the 2-point charges. Now, in your computation, do not forget to square the distance of separation between the 2-point charges. So if we will multiply this 2 divided by the distance multiplied by the k, were you able to come up with this magnitude? So the electrostatic force of attraction between the proton and the electron is equivalent to 8.20 times 10 raised to negative 8 Newton. Now, to calculate the net force exerted on a point charge due to multiple charges, you will apply the principle of superposition of forces. By using this principle, you can apply Coulomb's law to any collection of charges. The principle explains that the total force acting on the charge is the vector sum of the forces that the two charges would exert individually. Okay, so going back to our problem number 2 in our activity, the problem on the 3 charges on the line. So we've seen here that we have 3 charges along the x-axis, and we are asked to compute for the magnitude experienced by charge number 1. Our free body diagram looks like this. Now, since charge number 1 and charge number 2 have opposite signs, so they attract one another, then the force exerted on Q sub 1 by Q sub 2 is F sub 1 and 2, and it points to the left. Similarly, the force exerted on Q sub 1 on Q sub 3 is F1 and 3, and is also an attractive force, and it points to the right. Now, the net force is the vector sum of F1 and 2 and F1 and 3. To analyze this problem, we have first to compute for the force that exists between charge 1 and charge 2, applying Coulomb's law. And we need to compute for the force that exists between charge 1 and charge number 3. Afterwards, we will get the vector sum of F12 and F1 and 3. Now, using Coulomb's law, the magnitude of the force exerted by charge 1 and 2 is equivalent to 2.7 Newton, while the magnitude of F1 and 3 is equal to 8.4 Newton. Since in the free body diagram, F1 and 2 points in the negative x direction, and force 1 and 3 points in the positive x direction, then the net force is the vector sum of F1 and 2 and F1 and 3. F1 and 2 will have the negative sign since it points in the negative x direction, plus the magnitude of F1 and 3. So the net force on charge 1 is equivalent to 5.7 Newton, and it is directed to the right. Have you noticed the similarity between Coulomb's law and the universal law of gravitation? Now both follow the inverse square law. The difference is that the electric force can be attractive or repulsive, while gravitational force is always attractive. Now, one important clinical application concerning electrical forces is electrocardiography, or ECG. Now, let's find out the physics behind it. Electrocardiography, or ECG, is a technique for analyzing the condition of the heart. As each muscle cell in the heart contracts, positive and negative charges are separated. The polarization of the charges is shown in the screen. The effect of the charges separated across all of the contracting muscle cells at one instant time can be represented by a single positive and a single negative charge. The magnitude and relative location of these charges depends on the number and orientation of muscle cells that are contracting at one time. Since the heart repeats a cycle of contraction about 1 each second, it produces a charge distribution that changes magnitude and location in a repetitive fashion, once each second. At any instant of time, the electric charges on the heart exert forces on ions in the body surface tissue that cause the ions to move. For example, the charges on the heart force sodium ions in the tissue towards the left and the chlorine ions towards the right. Electrodes placed on the arms absorb charges of different signs. The heart acts much like a battery, pushing opposite charges in opposite directions in the body tissue. An electrocardiogram is a recording of the charge separation on the body's surface caused by the electric charge of the heart. Abnormalities in the size or timing sequence of different phases of the heartbeat cycle are easily detected by these electrodes. Can you now explain to your family how ECG works? Now it's time to write down in your notebook what have you learned in this movie. Please be guided with these 2 guide questions. How would you relate electric force to the magnitude of charges and distance of separation between them? And number 2, what problem-solving technique helped you to calculate the electric force on a point charge due to multiple charges? Do you want to have a challenge? I know you can do this. In the problem presented here, you will apply Coulomb's law, the principle of superposition of forces, and the component method in resolving force vectors. So there are 3-point charges that lie in the xy plane in a vacuum. Now find the magnitude and direction of the net electrostatic force on charge number 1. Now the force exerted on charge 1 by charge 2 is represented by F1 and 2 and is an attracting force because the 2 charges have opposite signs. It points along the line between charges. The force exerted on charge 1 by charge 3 is F1 and 3 and is also an attracting force. It points along the line between charge 1 and charge 2. Now using Coulomb's law, compute for the magnitude of F1 and 2 and F1 and 3. The net force is the vector sum of F1 and 2 and F1 and 3. Then use the component method to find the magnitude and direction of the net force. So, good job for solving the challenge problem. You are now ready to take the 10-item test. Congratulations! So this is the end of our session. I'll see you in our next lesson.